So in this problem, we're trying to travel from the island along the water and then along the land to point A. So we could take a path like this, straight to land and then straight across to point A. And that will give us minimize the time on the water. So our our velocity on the water is slow, and then we have maximum time on land. But the problem with that is that it's the most distance. If we try going straight there, that's the shortest distance, but because we're all on water, it's potentially the slower time because all on water, we're slower on water. So there must be some optimal angle that we can go at. So we go at and we hit the land, and from there we're going to go along the land to point A. So we try to maximize the amount of time on land, but we try not to make the distance too long. Okay, so we want to minimize the time. So we need an equation for time. Okay, our equation for time that we're going to minimize is going to be the time is going to be equal to the time on land plus the time on water. And to get the time expression, we're going to use time is equal to distance divided by velocity. So we're going to take the distance on water divided by the velocity on water, and then we're going to add that to the distance on land and divide it by the velocity on land. So we've been given the velocity on water and land. So velocity on water is 18 kilometers an hour. Velocity on land is 40 kilometers an hour. We've set up this system here. We're going to let this distance from this point to this point be equal to x, and then that makes the distance on the land, so the whole distance is 50, so we'll make the distance that we travel on the land as 50 minus x. Okay, so I'm going to just start setting this up a little bit here. Okay, so my time expression that I'm trying to minimize is equal to the time on the distance on the land, so d on land over velocity on land, plus this is going to be equal to the distance on water over the time on water, or sorry, velocity on water. So the distance on land is going to be 50 minus x, and the velocity on land we've been given as 40 kilometers an hour. Plus the distance on the water, this one's a little bit more complicated, but we do know that the velocity on the water is going to be 18. Now we want this in terms of x or theta. So in this case here, we're going to do this in terms of x first, and then after the fact, we're going to do this in terms of, we're going to solve for theta. Okay, so it's going to be much easier. We could set this up directly for theta, but it might be easier to work this out based on x. So I have here the distance on the water. We use Pythagoras. So we get 18 squared plus x squared, square root, and that's going to be the distance on the water. And then, so we're going to have the square root of 324 plus x squared as the distance on the water. So there it is. So I'm going to solve this in terms of x, and afterwards we'll figure out the angle theta. So there's my time expression as a function of x. So then I'm going to differentiate, get the derivative, and we end up with, in this case, negative 1 over 40. So the 50 differentiates to 0, plus 1 over 18, and then we're going to end up with 1 over 2 square root 324 plus x squared times 2x. So those 2's are going to cancel out, so we're going to have a few simplifications here. So it's going to look like this. negative 1 over 40. Okay, and this is going to end up with plus x over 18 root 324 plus x squared. Okay, and that's going to be equal to 0. So we're going to solve that equation equal to 0. X over 18 square root 324 plus x squared. And that's going to be equal to 1 over 40 when we move that negative to the other side. So cross multiplying this, I end up with 40x equals 18 square root 324 plus x squared. Okay, let me just clean that up a little bit, plus x squared. Okay, solving this, I end up with 1600 x squared is equal to 324 times 324 plus 324, so that's going to be plus x squared, and we're going to end up with 324 x squared. So expanding this out, okay, 324 times 324, couldn't need a calculator for that, but we'll write this as 324 squared plus 324. Make sure that's a little bit more clear. This is going to be 324 times 324, and then x squared. Subtract 324 from both sides, I end up with 1,276, it looks like, x squared, and that's equal to 324 squared. Okay, solving for x, we get 324 squared over 1276, and then we get x is equal to plus minus the square root of that, so square root of 324 squared over the square root of 1276. Okay, so we can work out that decimal value if you like, but we can also simplify this. So this is, if we divide the perfect squares in there, we're going to end up with, oh, what is that going to be? Okay, so I think we'll just work that out as a decimal value.